In this lesson, we will use the OpenSSL utility to assess organizational security. We are in the OpenSSL portion of the video series. This lesson is part of a video series that prepares you for the hands-on portion of the CompTIA Security Plus exam and is designed to give you hands-on experience with the exam. So what is OpenSSL? The OpenSSL command is a command line tool used for working with SSL, TLS protocols, cryptographic operations, and managing certificates. It is used by system administrators, developers, and security professionals for managing and testing cryptographic functionality. It is used when managing secure communications, generating certificates, or performing cryptographic tasks such as encryption, decryption, certificate validation, etc. It is available on most Unix-like operating systems, including Linux and Mac OS, and can be run in a terminal or command line interface. It is used to ensure the security of communications through SSL, TLS, encryption, manage private keys, and handle cryptographic algorithms for secure data transmission. The command is executed in a terminal, followed by specific subcommands and arguments, such as OpenSSL gen p key for generating private keys or OpenSSL rec for creating certificate signing requests. The rest of the how is what this video is all about, so let's get into it. To get started, grab the companion guide from the link in the description below. Also, if you like this content, please like, share, and subscribe to the channel so you won't miss any new videos. Okay, and we're back. And we're all set. We have our companion guide on the left here. We have Ubuntu Linux on the right. In this exercise, we do not have to install anything, so we can get right into it. I'm going to Control-Alt-T to get into a terminal session. As you know, there's a variety of ways of doing that. I'm going to expand it. Control-Shift+++, just 3 times. If we need to shrink it, we can. I can always just go back and make it smaller with the minus. And I think this looks about right. So what we're going to do is just real quickly, we're going to create a plain text file that's going to be a simulated secret message. So I copy that into clipboard from the companion guide, or you can type it, and it's echo. This is a secret, and we're going to pipe it to a secret.txt file. We did that. We're going to ls, see what's in there. We see the secret file, and we're going to cat that secret file, and we see that's our plain text file. Now we're going to encrypt that. So the whole idea is that we want to encrypt this file. So let's go ahead and get this command, and we'll break it down in the command line. So I'm going to bring that over from clipboard into the buffer, and we see we're going to use the OpenSSL command. We're going to use the encryption, AES, Advanced Encryption Standard, 256-bit, and we're going to use the cyber blockchain. And we're going to use assault, which is a random character, and the input file is going to be the plain text file that we created, and the output is going to be the secret.enc. That's going to be the ciphertext. Now, as you may remember in class, if you're doing this in self-study or looking at other videos, Advanced Encryption Standard is asymmetrical encryption, which means that same key to encrypt is the same key to decrypt. So we're going to put a password in here, and you must remember this password. So whatever you select, you have to remember. It's going to ask you again, and it says great. We get a warning. It says that the deprecated key derivation used, it says we should probably do something else. Okay, so let's just see what happened first and foremost. So we have the file, it's there. Let's take a look at it. Cat secret. We're going to try and cat that file, and we see assault, and we see the encryption file. And technically we can keep this, but we did get a warning. So let's go ahead and deal with that warning. And basically what the warning is telling us is that the default key derivation function it uses was not as secure. It's suggesting that we use the password-based key derivation function to this acronym here. So we're going to rerun that command slightly differently now. It's the same thing as we did before. I'm going to copy that, bring that into buffer as well. And the difference that we're going to see here is after the salt, we're going to call the password-based key derivation function 2 into this command to make it more secure. So we're going to rerun that plain text into the encrypted text, put in the password, We have to verify that password because it is symmetric encryption, means same key to encrypt is the same key that decrypts. And we're going to take a look at our plain text ciphertext again. So I'm going to cat the plain text file, which is the secret.txt. And then we're going to cat the secret, the encrypted file. And we see it has a salt and the encryption. In other words, we can't see the message in there and we have good encryption. So let's go ahead and do some housekeeping. Our next step is to go ahead and actually decrypt the file and see what the reverse function looks like, because as with many things in class, it's two sides of the same coin. So we already catted the file. Let's go ahead and clear. I'm going to cat the file once again. It's the secret.enc, and we see that file there. Now we're going to decrypt it. So we're going to decrypt the file. I'm going to hit enter so that way we have a little bit more space. I'm going to copy the OpenSSL command again. Put that into clipboard, bring it over to the Ubuntu side, and let's analyze this. So we're running the OpenSSL command. We're still using the AES 256 encryption algorithm, and this time we're calling the -D for decrypt. We know that it has a salt. We have the password-based key derivation function 2. The input file now is going to be the encrypted or the ciphertext, which is secret.enc. And now the output, we want to decrypt it. In other words, we're decrypting this file. So we went through all of these little functions here. So we hit enter. It asks us for the password. It's symmetric encryption. So same password to encrypted is the same password that decrypted. And now we have done that. Let's ls. We see that decrypted file there. Let's cat the decrypted text. And we have now reversed the process and have decrypted that file. So excellent. So we're going to tick off some of these boxes as a review. So we catted the file, we ran the command, we encrypted, used the AES 256 algorithm, salt, the password-based key derivation function 2. The input file was the ciphertext, and what we got was plain text again, and we catted the file so we could see the contents. Let's move on to something a little different. We're going to now create key pairs. So as you know, there's a public key infrastructure where we can use key pairs, a public key that we make public, a private key that we keep private, and we can take someone's public key, encrypt something, and only they can decrypt it with their private key. So let's go ahead and see what that looks like. So we're going to take this command that you see here, OpenSSL, and let's break it down a little bit as we copy it into clipboard and I bring it over into the Ubuntu side. So we're going to OpenSSL, which is the whole point of this tutorial. We're going to generate a PKER, a private and public key pair. We're going to use the RSA algorithm here, which is asymmetric. It's two keys, a private and a public. Now the output file is going to be a private key, and this is the algorithm that we're going to use. Well, when I say algorithm, this is the key size. We're going to use a 4096 or 4000-bit key for enhanced security. So we go ahead and create it, and that took less than a second or so, and then we should have a star.key file. Let's see, what do we have? We have a private key. Now, generally speaking, this is a tutorial. We never share our private key, but let's go ahead and just take a quick look at that private key. So I'm going to cat the private key, and it tells me that it's a private key. It says begin private key, and it has end private key on the bottom. So I'm going to clear the screen to get it back on top. And now we created the key pair. Inside this private key is our public key. So we need to extract that. So right now I'm just going to do an ls. I'll do an ls minus long so we can see it in format here. So we have our plain text that we created, our ciphertext, then we decrypted it, and now we went back to plain text again. We just created a key pair, the private key, but now we have to extract the public key from the private key. And we can use OpenSSL to do that. So we're going to extract the public key. So we go ahead and run this command. That command is OpenSSL. We're using the RSA encryption, which is an asymmetric. It's two keys. And we're using the private key is going to be the input. And we're going to pull out the public key. and the output is going to be public.key, is going to be the key file. So hit enter, and it wrote the key as it told us here. And now we're going to run ls again, -long, and now we have the private public key. Now both of these are linked together. They're mathematically linked. We need both keys to work together. So again, the public key we keep public, the private key we keep private, and we can encrypt someone's data with their public key, and they're the only ones who can decrypt it with their private key. Okay, so we have done that before. Let's go ahead and clear. And by contrast, we saw the private key. Let's go ahead and cat the public key. Now this one was a typographical error on my part, so I'm going to just basically exit out of that, and I want to cat the public key minus this error here. And you see the public key is much shorter. Okay, so it begins with private key, the private key, public key. Now a couple of things as we do some housekeeping here is that you never ever share your private key with anyone. Because they would be able to decrypt information if you are in a PKI, a public key infrastructure. So a couple of things you do is you should never share it. You store it in a secure location, and you can put a password protected file with strong encryption. So let's combine what we've done so far. We have decrypted a file, we made key pairs. Well, let's go ahead and encrypt it with the OpenSSL command. So we're going to go back and basically do what we did before in step 1, which is up here where we did encrypting and decrypting data. We're now going to encrypt our private key using symmetric encryption. So we're going to go back to open RSA. We're going to in private. So you see this portion here. Let's make sure we have that. Yes, in private. We have that set up here. We have in private key. Let's set that up. And this is now writing the password. So essentially we're encrypting it. Now it says enter a PEM password, which is privacy enhanced mail. We'll talk about that a little bit. And now let's go ahead and use a password for that. And now we have encrypted the private key. How do we know? Let's go ahead and take a look at it. So we have our keys. Let's do it the long way. And now we have our private key that is encrypted and our regular private key. So let's go ahead. Again, this is tutorial. We never share it with anybody, and honestly you wouldn't be able to do much by looking at it. I'm going to clear the screen. I'm going to cat the private key so you can see what it looks like. And it says it begins with the private key. And let's get a new tab over here and make that a little bit bigger so you can see we're still in the same folder here. Now I'm going to cat the private underscore encrypted key, and you're going to see a difference here. It says that this key is encrypted, and it has the AES 256 CBC, the chaining. So we have our private key, which is unencrypted, and now in this case here we have encrypted it. Just as an added measure of protection, I'm going to Control C to clear out of this. We have our files, and we see the permissions, and both our private key and private encrypted key are essentially only available to us. Read and write only for the owner. The other group doesn't have access to it, and the no permissions. If you're not sure, you can just chmod. So we can do change mode 600, and we have a tutorial on that on chmod. We'll actually change mode the key so that way it has that permissions on it. Now we already have it, so you're not going to see a change on it, but the read write to make sure that we're the only ones who have access to the key. So let's take a look at a couple of files that we saw here. So there are common types of PEM or privacy enhanced mail. Honestly, it's not used as mail anymore. It's usually for certificates and private keys. So we saw the CRT key. We're going to take a look at a security key in a second. But let's go ahead and looking at hashing passwords and just adding a salt onto it, because we saw that before. By default, OpenSSL does that. So first, let's see what it looks like on regular online generator. So I'm going to go to SHA-512 online. I have it up here, and I'm going to create a regular hash of the word password. No new line. I don't want to generate a new line. And you see it's B109 Foxtrot 3 Bravo 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 Charlie 244. So I can run the same command here as well. I can do echo, so that way you can see where I'm getting that from here. I can do a regular password, which is echo, no new line, same thing that I mentioned here. I don't want a new line here. I want to go no new line password, and I'm going to pipe that into the SHA-512 sum function in Linux. And I get the same output here. You see I get the B109 Foxtrot 3 BBBC 24, and then you see the same thing over here. By the way, if I do a new line here, I do enter, I'll get the 914, and if you see that error, it's because the new line is actually seen differently. So if without the new line, I say no new line here so I can pipe it directly. If I pipe it with a new line into SHA-512, it's going to look different the same way it looked different here. We have parity here only because I removed it. So if I get rid of the new line, I generate the hash, it goes back here. If I come back on the Linux side and run it without a new line, it comes back here, everything is in alignment. So we can do this, and as you see here, we have a hash of the word password, and we can always repeat it, and we know what a hash is. That's one of the things we can do, is that it's a one-way function, fixed length, and it's always consistent. The word password will always generate this hash for SHA-512. Same thing here. So we're going to do something different here. On OpenSSL, we're going to actually add a salt to this hash. In other words, we're going to put a random character, and that's going to protect this file from a rainbow attack, which was the previous lesson. So instead of sitting here running pre-computed tables of rainbow tables, we can add a hash on it to make it much more difficult. So the command is going to be OpenSSL, and we're going to call the -6 function. So I'm going to put it in here, -6. And the reason why -6, I want SHA-512. And that is recommended as the strongest one. Can you do SHA-256? Absolutely. We're just going to do SHA-6. We're going to put in the password for that. Make sure I remember my password. And now it has created that hash. And that hash is now salted. It has an extra little piece of data in there. So let's go ahead, and one more thing that we want to do is take a look at, and let's just do a little bit of housekeeping. We can always come back and do that towards the end of the tutorial. Don't want to use your precious time for checking off boxes. Now, let's go ahead and just compare these. So as you know, we can do a verify the hash of a file, let's say the SHA-SUM hash. Let's do an ls and see what files do we have here in terms of secret. So we know we have a secret.txt, and let's say we wanted to find the hash of that. So we're going to do SHA-256. In this case here, I want to do a SHA-256 sum of the secret.txt file. It's going to generate that number. We can use OpenSSL as well to get the 256 SHA hash as well. So this is essentially typing OpenSSL, the digest. We're going to use the SHA-256 algorithm, point it towards our file, and we get the same output. So you can use regular SHA-256, or you can use OpenSSL to generate the hash of a file. So you can return a hash as well. Another thing we can do is to see that if verify the integrity of a file. So we had our secret file in here. Let's just see what all of our text files are. I need to be on this side of the house. And let me just fix that so that way we have our command lines looking good. So we know that we have a couple of decrypted files here. So this plain text file was the original secret.txt was the original plain text file. We encrypted it and received a secret.enc, and then we decrypted it into a plain text decrypted.txt. Perfect. Now we want to see if these hashes generate the same thing to make sure that these files are the same. So we go ahead using OpenSSL. The digest is going to be SHA-256, and see if they compare. So we OpenSSL digest 256 secret.txt, and it generated that file, that hash. Now we come over here into decrypted, and we get the same thing, and we know that that file is identical. Although the name is different, the content of the file identical, the files are identical. Okay, great. Now, let's go ahead on to creating and managing SSL and TLS certificates. But first, let's go ahead and take a look at one. So I'm going to go over to my browser. I have pfSense. It's HTTPS, which means that it's secure, port 443 for HTTPS. It has the lock to show that it's secure. It says the connection is good. We can get some more information, and we can view the certificate of this server. Now, the browser trusts a certificate authority. This is like your ID card. So this is the server's ID card, or pfsense.org's ID card. It gives us the country name. It tells us what's the organization, the type. This is, again, like your driver's license. It's going to tell us that this is when it's valid. So we see its range here. It's not valid after May 6, 2025. Not valid before February 5th, 2025. So we get some information here. And this is, once again, the ID card or the driver's license. And this is, if we're going to use a driver's license analogy, this is a government issue driver's license. But maybe we want to create our own. For example, if you're running your own organization, you have a nonprofit and you want to run your own ID cards, well, you can also create your own certificates, and OpenSSL can do that as well. So we're going to go ahead and do that. So I'm going to come back on the Linux side, and we're going to actually put in this command, and we'll break it down after we bring it over to the Linux side. So it's going to OpenSSL. We're going to use the X5.09. It's a new key, RSA. This is the key size, 2048. We're going to output the key. It's going to be called server.key, which aligns with our PEM file standards. So this is going to be a .key for a private key. And we're going to output that into the server.crt. This is going to be the certificate. So PEM files also contains the public key certificate. And we're going to validate that or generate that for 365 days. In other words, a year. Okay. So I'll come back on this side here. This is a brief explanation of the command. It's asking us for a privacy enhanced mail phrase, a password to create that certificate. We're going to type in a password. And remember, you have to remember all of these passwords. And it says, go ahead and create our certificate. So it's asking us some on-screen prompts, so we'll go ahead with it. So country name is going to be US. The state, I'm in New York at the time, is going to be New York City. The company name, we're going to say is Tech Made Easy. And the organization users, let's go with Cyber Labs, which is what we've been doing 007. And enter my name. So I'm going to put in my name. And the email address, I'm going to go ahead and put in my email address as well. So I'm going to put in my Gmail address in there. And it's all set. So we have created our own certificate, and let's go ahead and take a look at that certificate. So we're here at verify the certificate. So I can cat the certificate, and let's see what it looks like. So server.crt, not particularly helpful. So let's clear that and run that again so you can see what it looks like. Okay, it does exist. We can actually go ahead and use this command and look at it from OpenSSL. So OpenSSL using the X509, we're going to look at the certificate, and we're going to output the contents of that certificate. And we start to see a lot of the information that we saw when we went to pfSense. We saw the begin certificate. We start to see the algorithm, the validity date of that file, which is we just created it, so it's good for 365 days. This is the time, and this is all the information that we put in, the country code, the state, the location, the organizational unit, the name, the email address, and we see that there. But we can also see this in Firefox. So if I'm going to go back to Firefox here, and just so we know where we are, I'm going to clear the screen and ls, and let's do the ls minus long, and I know I have a cert here. So the name of the certificate is server.cit, and it's in my home directory, so tilde. So the path is tilde secret.crt. So I go to Firefox, I'm going to open a new tab, and I just want to go to my home directory / server.crt, and I want to open that certificate. And it's going to open that certificate, and it has, wow, my first name, just as we expected. When does it expire? A year from when this was created, because we put in 365. Here's the subject name, the country code, New York, Tech Made Easy, Cyber Labs. It has all the information that we created here. So this is how we can use OpenSSL to create a certificate if you ever have to self-sign, as the term goes, self-sign a certificate. OpenSSL can be used to do that. Okay, so I'm going to do a little bit of housekeeping more for field positioning. We need to know where we are. And I'm going to open up this SSL Labs because we're going to look at testing secure sockets layer, TLS connections, on pfsense.org. So we can use a web interface to do that, right? So we can use SSL test. So we can do this real easily, and I'm going to put pfsense. So we do pfsense.org. We're going to submit, and we're going to let that run for a while, but I am going to snag that IP address. 208.123.73.78 is the IP address. It's getting a grade, and it gave it a grade here. We could do this on a website, but we can also go ahead and do this at the command line as well. To do this at the command line, we're going to use this command. So let's go ahead and get this into clipboard, or you can type it. I'm just doing this in the interest of time. We'll come back to the command line. I'm going to clear the command line and go ahead and take a look at this command. So we're OpenSSL. We're going into the client. We're going to connect at the IP address of 208.123.73.78 on 443. In other words, we're going to pfsense.org, renew the IP address because we could see it here, 208.123.73.78, and we're going to use 443 to show its certificate. And we hit enter, and we get that certificate. Now, it's a little easier on the web interface, but there may be reasons we may want to do this because we want to script it. As you know, there's a tutorial on bash scripting. We may need the command line to start grepping and looking for specific pieces of information, and all of this can be automated. One of the things that we do in class and in practice is that we standardize, we optimize, and then we automate. And the way we do the automation piece is that we do it with scripting. So we want to know how to do that. Granted, you can use SSL Labs, but it's a little bit easier to go ahead and take a look at the information. So we see one of the problems here. We see this service certificate chain is incomplete. So that's why it got a B. The information is actually here where it tells us that it is unable to verify the first certificate, which is why it couldn't do the chain. And you can read it in the text, but sometimes it's a little bit easier on the graphical user interface, which is why we're showing both. So we'll go back to our lab here. This connects the pfsense HTTP UI on port 443, which is why we called it out in the command, and it's just going to see the details of the certificate. Okay, let's move on to something a little bit more robust here. We're going down to look at TLS. So in class, we talked about the transport layer system, or TLS. And in TLS is the secure transport layer protocol. And we should be on 1.2 or 1.3 based on compatibility. 1.1 is no longer supported or considered secure. So we just want to make sure that this side is fine, and we see that it is, and we see the different cipher suites for TLS. Let's go ahead and actually do this once again at the command line. So I'm going to clear the screen to get it on top, and I'm going to pick up this command here and purposely pick TLS number 1 so we can see what that looks like from a TLS number 1 and make sure we're going to the right place. So we're OpenSSL, we're connecting to pfsense.org. You can call it by DNS if you need to. It's interesting, it's possible that I don't have DNS set up on this, so we may have to call that out by IP address. So just give me a moment while I put in the IP address of the server. So here's where we are. This is a newer install of Ubuntu, and DNS isn't working on this one yet. I can easily configure that, but I just, in the interest of time, wanted to just quickly show you that we did this slightly differently. I picked the IP address of the pfSense server because we had it here, 208.123.73.78. We could ping it, we can NS lookup, we can do a variety of things. And I see TLS1, I see I'm connected, no peer certificate available, no client certificate CA names sent. So this is not what we're looking for. Secure renegotiation is not supported. So we don't want TLS1, we already know that. We want TLS2 or above. And now we get a certificate. And now we have TLS, we can check this. It's the same thing as going through this process here on a web interface. However, we're using OpenSSL to do that. And if we want to, I'm still on this end here. I'm going to bring that back on top, and we can do TLS3 as well to make sure we have those connections. And we see we have the certificate, and we can go ahead and read the information here. So we can do this a variety of ways, and it gives us the details that you can pull either from a web browser, or you can use OpenSSL to do this from a command line for either readability, for optimization in terms of grepping the information out, and we have a tutorial on grep, which will just extract the information that you're looking for, or you can also use this in scripting to pull out the information. So that's what we did. We did a lot. This was a good tutorial, and I try to keep these to about half an hour. That's what the labs are like when we're in class. So let's go and clean things up a little bit as we wrap up. This is a good buddy lab. I recommend, as you hear me say in class from time to time, labs work best when they do not work at first, and even if they do work, you should do it again, and if it doesn't work, you should do it anyway. So you're going to do these over and over again. On that note, what did we do? We encrypted and decrypted data using AES 256. This was the secret text, and then we took it to decrypt. We generated the RSA keys, so we generated a key pair. We had the private key, then we extracted the public key, and we secured the private key. We also created self-signed certificates by using the OpenSSL to generate our own cert, and these files are sitting over here. So these are all the different files that we looked at, and you can do them yourself. I'm going to do ls-l so you can see that. We also did some hashing passwords for file integrity. We wanted to check to see if the decrypted text was the same as the secret text. Both were ciphertext. The difference is that the secret text went into the encryption, which generated the ciphertext of secret.enc, and then we decrypted that and got the decrypted.txt. We compared them to make sure they were fine, and then last but not least, we tested SSL TLS connections on pfSense, and we can use other websites as well. Or you can use OpenSSL Labs if you need to do this from a web utility. So that's it. We're about half hour in. This is where you can get additional help on SSL. So I'm going to clear the screen on the Ubuntu side. There's nothing to install as part of the default install. I do OpenSSL. I actually have to quit out of this because really to get the help, you just type in help and you see all the different types of commands. You can always man the command as well too. So we can man OpenSSL and you get the whole manual page. So that's where we are. As you know, this is just the tip of the iceberg with all of these commands. There's so many more or different things we can do. The intent was to give you some awareness about the command, get you familiar with it as you continue with your preparation for the CompTIA exam, and or if you're just upskilling or learning about these commands in your class and just needed a lab to go through the process. I hope you enjoyed this lesson. As always, I enjoyed preparing and delivering it. We have more to come, so stick around and hope to see you at the next lesson. See you soon.